In this section, we're going to cover a concept called random variables and distributions. And more specifically, we've already talked about distributions. We just called them distribution tables before, probability distribution tables. They're back, and we're still not going to do anything with them. But that's okay. We'll do it in the future. It's going to come together. It's going to make sense soon. So, three big ideas from this section. Can you define a random variable? Okay, so that's going to be A number one. Just can you figure out what a random variable is and how to define one? Then, can you create a probability distribution table using random variables? Okay. Then also identify discrete, continuous, finite, and infinite random variables. So four keywords there: discrete, continuous, finite, and infinite. Okay, so there's going to be four types, and they're not it's going to be a combination of two each time. So four kind of vocabulary words. All right, let's get started. This is going to be, you're going to like this section, I promise you. It's nice and it's fun. All right, so first things first, do you remember how to make a probability distribution table? If so, I would like you to do that. Make a probability distribution table describing the number of heads flipped when flipping 3 coins. Okay. If you don't remember, that's okay. I'm going to walk you through it right now. So the first things first, you start off by saying the events, right? And so in this case, it's going to be the number of heads flipped, or just call it number of heads. Then the other column to our table will be the probability of getting that number of heads. Right? So if we're flipping 3 coins, what are all the possible outcomes that you could get when flipping coins and counting the number of heads that you got? Well, I could get 0, right? All of them would come up tails. I could get 1 heads, 2 heads, or up to 3 heads, right? All right, this table is a little long. Let's shorten that down. All right, so now the question is what is the probability of each of these things occurring? What is the probability of me getting 0 heads? Well, now this is just a basic probability problem that you've been doing in all the other sections. So now we just do them one at a time. We say, okay, what is the total number of outcomes when I'm flipping three coins? Well, first coin, 2 choices, 2 choices, 2 choices. First coin, second coin, third coin. 2 times 2 times 2, that makes 8. So therefore there's 8 possible outcomes. And the nice thing about these is all of these always have the same number of total possible outcomes because it's the same thing. It's the same situation. We're flipping 3 coins, 8 possible outcomes. Now, how many of them result, how many of those flips result in me getting 0 heads? Well, there's only one way for that to occur, right? It has to be tails, tails, tails. Similarly, how many ways are there for me to get 3 heads? Well, that could be heads, heads, heads. There's only one way for that to happen. Now, how many ways are there for me to get 1 heads? Well, then that would mean if I get heads on the first flip, then I get tails, tails. Or if I get heads on the second flip, then I get tails on the other ends. Or if I get heads on the third, then my first 2. So there's a total of 3 possible outcomes. And you could go through the same logic again, or I'll do it using permutations and combinations. What I'm saying here is, all right, I need to rig the game. I need to guarantee I get 2 heads. So out of the 3 coins, I'm going to choose 2 of them to get heads, which therefore means out of the 1 remaining coin, I'm going to choose 1 of them to get tails. So 3 combinations 2, that's 3. 1 combinations 1, that's 1. So it gives me a total of 3. And so therefore we now have our probability distribution table. Yay! And what is the key traits of a probability distribution table? It needs to list every possible outcome, and because it does that, the probabilities should always add up to make 100% of your outcomes. It should be 100% probability that one of these things will occur. And when you add them up, we see 1 plus 3 plus 3 plus 1 makes 8 over 8, so that is in fact 100% of our outcomes. Looks good, looks good. All right, so that's a refresher on how to make a probability distribution table. So now, what is a random variable? Because that was our first bullet point. We need to be able to identify random variables and be able to define them. So a random variable is simple. It's just a variable that assigns a numerical value to each outcome of the probability distribution table. That's what we did, right? Instead of writing out 3 heads, or sorry, well, that would be 0 heads. 0 heads, I wrote the number 0. Or instead of writing, I could get tails, heads, heads, or heads, tails, heads, or whatever. We just said no, 2. I'm going to call it the number 2, the number of heads. So we already did a random variable. All it is just taking kind of an abstract idea and representing each outcome with a number. All right, so then the only change here is I actually have to define the variable. I'm going to say let my variable x equal the number of heads flipped. So then in my table, instead of actually writing the whole thing out, I'm just going to say x. That's my variable. So therefore, now down here, we're going to say what is the probability of x. That's it. We're done. That's it. So we just rewrote this probability distribution table using random variables, because I wrote this statement right here. This moment right here is where the random variable kicked in when I wrote down let x equal the number of heads. Great. Okay, so now a little bit of practice. You do this one. Let x represent the number of green marbles in a set. When pulling 4 marbles from a bag containing 3 red, 2 green, and 5 blue. So can you create a probability distribution table with that in mind? Okay, give it a shot. I'll pause the video. All right, here we go. All right, so they already told you. Let x represent the number of green marbles in a set. All right, so therefore, in our table, we're going to let x, we're going to do probability of x and x. Okay, so now all of our possible outcomes for x would be the number of green marbles. So if I am selecting 4 marbles from a bag, then I could theoretically have 0 greens, 1 green, 2 greens, 3 greens, or 4 greens. Well, except there's only 2 of them in the bag, right? So therefore, it would be impossible for me to get 4 or 3. And is it possible for me to get 0? So this is a question we need to ask ourselves. We say, well, because there are 3, I'm picking 4 marbles out of the bag and there's 3 reds and 5 blues, it is possible. There are enough other colors that I could get 0. So this is working. Okay. So here we go. So we're going to say, all right, total possible outcomes for each of these events. Well, how many marbles are in the bag in total? There's none up here. So 3 red, 2 green, 5 blue. So that makes a total of 10 marbles. And out of the 10, we're going to select 4. So it's 10 combinations 4. So each of these probabilities will be 10 combinations 4 for the denominator. Now for the numerator, how many ways are there for me to get 0 greens? Well, then that means out of the 2 greens, I'm going to choose 0 of them, which makes 1. So I don't have to write that. So instead, we're just going to say there are 8 other marbles in the bag, right? 3 reds, 5 blues, and out of those I need to select 4. Then for 1, all right, well, out of the 2 greens I need to select 1 of those. Whoops, and then I didn't leave myself enough space. I'm going to cheat here, give myself a tiny bit more space. Okay, so out of the 2 greens I need to choose 1 of those. Then out of the 8 other colored marbles, I need to choose 3 of those, and that will go together to make a total of 4. All right, here we go. Now, for 2 greens, same thing, denominator still stays the same. Okay, out of my 2 greens, I need to select 2, and then out of the 8 other colors, even though I have 2 greens, I still need others, so therefore I need 2 of those to make a total of 4 marbles. And there's my probability distribution table using random variables. All right, what did you learn new here? Yeah, nothing, I know. Okay, and this is a good place to stop. I'll see you in the next video.